work on the DNA worksheet. We get a link for everybody in the Discord. All right. You guys hearing me okay in the Discord? Hello.
All right. You guys hearing me okay in the Discord?
Yes.
Hey, Delani, you need to set your push to talk.
Yes.
Hey, Delani, you need to push to talk.
Yeah, there's a lot of just feedback through it.
One second,
Yeah,
I'm getting
there's
this worked out. It's going to cause feedback. All right, that's better. Yeah, so if you want to talk, just use your push to talk, and then it won't cause the feedback like that.
That's better. Yeah, so if you want to talk, just use your push to talk, and then it won't cause the feedback like that. That's better.
All right, let's try this. All right, guys. So I wanted to work on the DNA worksheet. I did have it pulled up. Let me right here. Let me switch over. All right, this worksheet here. Some of you guys said that you started it already. I just want to go ahead and work through some of these problems. So the first one here is to draw the structure of this nucleotide. And you're given the pieces. Remember, you have your phosphate group, your 5-carbon sugar, and then your nitrogenous base. All right, so let's go ahead and put it together. There is a picture I wanted to reference. Give me 1 second, I'm pulling up a file. Means where'd it go? All right, so what I want to go ahead and do is just switch over to the document camera view, and then I'll go ahead and draw this. Trying to figure out the best view for this. All right, so let me scroll this to the top. Hope you guys can see that okay. Not covering it up too much. All right, so the way you want to connect these is between each of your, let me use the mouse here, between each of your groups here, you have an OH, and they are going to connect by a condensation reaction, and you're going to basically lose a water molecule. They're going to be bonded to each other, sharing their oxygen. So your phosphate group is going to be like this. Like that. And then this is our OH that I'm drawing here. This is going to have a bond to the CH2. That's part of your ribose there. And then we have our sugar piece. And then we have our hydroxyls here. And then I could ask a couple questions about this, but all right. So where the OH is here on the anomeric carbon, that's going to be bonded to the NH that's on the bottom left of the ring there on the nitrogenous base. So instead of having the oxygen here, we have nitrogen, like that, and then you just draw the rest of the molecule. That, and then we have our other ring over here. Feels like we're in art class today, doesn't it? Like that. And there we go. Do you guys have any questions about this drawing? Any questions?
Yes, how do we know which nitrogen to connect it?
I do have a handout that shows it to you. I think it was in the handout itself too. Let me check this real quick. I think it shows it in here. Oh no, it doesn't. Oh, right here. Actually, they do right here. So this one shows you a couple examples. You guys seeing this?
I think it shows it in here. Oh no, it doesn't.
Wait.
Oh, right here. Actually, they do right here. So this one shows you a couple examples. You guys seeing this? I think it shows it in here. Oh no, it doesn't.
Feedback. Feedback.
Oh, right here. Actually, they do right here. Yeah, this one shows you a couple examples. You guys seeing this? I think it shows it in here. Oh no, it
Giovanni,
doesn't.
you need to. Yeah. Yeah, this picture right here in the handout shows you how the connectivity goes. Like so. Does that make sense? How it's showing the connectivity? All right, but we're not going to go into a lot of detail of which one. I think if I gave you guys the drawing here, I would specify which one I would want you guys to work with. I probably wouldn't honestly have you guys draw this on a test. This would be more like a quiz situation. But yeah. So the kind of question that I can have here, I want you guys to help me with right now, is this a DNA or RNA nucleotide? DNA or RNA?
RNA?
And how do you know that? How do we know-
There's an oxygen on the sugar. I just can't remember which
Yeah,
carbon.
it's carbon 2. So remember, if you're numbering on the sugar, carbon number 1 is here, the anomeric carbon. And we use the prime numbering here, so I'm going to add primes to all these. Prime, 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 prime. So the 1 here, if this has an OH, this means it's ribose. This is RNA. If you're missing that OH, it's deoxyribose. All right, another question I could ask you guys here would be whether or not this is the alpha or beta anomer. And we figured that out by looking at the anomeric carbon. Yeah, it's beta.
Is it alpha?
It's beta. So if the heteroatom that's coming off here directly, meaning your non-carbon, non-H, if it's going upward, it's beta. So beta. There. All right, the next question, let's go back over to this. The next question here is asking you about the adenosine triphosphate. How did that differ? Basically, how this is different is we have 3 phosphate groups. So if you're drawing that in the shorthand here, phosphates are shown as just P, like that. And then you have your sugar. And then you have your nitrogen compound. That. All right, this is adenosine. So the adenosine comes from which base is attached, and then triphosphate. And this is ATP for short. We didn't go into detail with this. This is actually from the metabolism chapter. For any of you guys taking your biology already, this is a biologically significant compound. This is basically an energy molecule. We're not going to go into why I decided to cut that chapter out, but this is an energy molecule here. All right. The next question here is asking you about the abbreviations. So the abbreviations, basically, let me switch back over to the view. The abbreviations we use here, the first letter is whatever nucleotide, whatever nitrogenous base is involved, and then the next two letters are whether it's monophosphate, diphosphate, or triphosphate. So it's going to be AMP for the one we just did, and then this would be GMP, CMP, UMP. The first letter comes from which base is attached. All right, and then if you have the deoxy version, you add a lowercase d in front. So putting this last one together, it's a deoxythymidine. So that's thiamine that's part of it. So this would be DTMP. Let me show you guys here. So for number 3, you make sure to get all these in here. It was GMP, CMP, and UMP. And then 4, keep switching over. Bring the camera back up here. All right, there we go. All right, so this is asking for, God dang it. That one. That. So DTMP. All right. So the next page is kind of the same thing again, really similar. Provide the products for the following reaction. So we're showing the condensation here. So number 5, let's go ahead and do this one. Let me zoom out a little, make it a little bit smaller, maybe be able to fit it easier into the stream. Yeah, that's better. All right, hopefully you're able to see that okay. So I'm going to go ahead and show connectivity with the lower nitrogen. So we have our regular ribose again. This is a DNA fragment. We have the beta anomer. And instead of having an oxygen here, we have nitrogen. And I'm going to connect it to the bottom nitrogen. So then 1 carbon away, we had double bond O. And then nitrogen. And then double bond O. And then I think we had a double bond over here. So I did turn the molecule a little bit, but it's the same thing. I just turned it. All right. The other one wants you to do the same kind of drawing with thymine, but it also is specifying deoxyribose. So I need to pull up what these are. So there we are. Thiamine is similar. Looks like we have an extra methyl group on there. You guys see that? Wait, I think my drawing here is in the way. We should turn this off. All right, so we're going to use the thiamine here. We're going to have it connected to this nitrogen here in the bottom. So it's going to be the same kind of drawing in a lot of regards. So switch back over. Oops, there we go. So I'm going to slide this drawing over here. So we're working on number 5 here again. Just make sure you guys are clear which one we're on. We're number 5. That. Extra methyl group over there. They're really similar. All right, and then deoxyribose, I'm going to make sure that I don't have this OH here. All right. You have any questions about these ones? Oh, and if you're worried about mass balance here, guys, you could write plus H2O. Remember, you did lose a water molecule here. Yeah, if you guys have any questions, feel free to stop and ask. All right. So this particular page is only really one question at the bottom. Most of it's just kind of explaining what's going on here with the structure of DNA. So remember here that they will pair with their complement base pairs on the other strand, and the other strand reads in the opposite direction. So I did want to do some practice problems where we have to utilize this here. We're going to skip that one out. This one, just read it, basically. But I want to go ahead and take a look at number 7. So the question I have for you guys, do you guys know what pairs with what? Like which, so A pairs with, so A, T, G, and C. Okay, what does A pair with? Do you guys remember this? Yeah, A goes to T, and then the T goes to A. G goes to C, and then C goes to G. Do you guys remember what nitrogenous base is changed out for RNA? So this is for DNA, but one of the bases is different in RNA. You guys remember which one it is? Which base is different in RNA? Let me check the Discord chat. You guys are putting in the chat. Yeah, T becomes U. So in any situation where you would see T, just plug in U. So it's A to U, U to A, G to C, C to G. All right, so this question here is asking you to draw the complement pair. So you just need to basically write their opposites there, and you also need to specify your ends. So I'll go ahead and copy that chain there. So it's AAT, so it goes TTA, and then TCC. Wait, A, and then C goes to G, G, and then GCT. So that becomes, hang on, right there. I lost my spot. So G, so C. And then T goes to A. And then it's AA, so it's TT. And then CG, so GC. And then, yeah. All right. So the question I have for you guys now is this now reading in is it 5 prime, 3 prime, or 3 prime, 5 prime? So the question after you guys is the left side here is the left side here 5 prime or 3 prime?
3 prime, 5 prime.
Yep.
And for you guys, is the left side here is the left side here 5 prime or 3 prime?
3 prime, 5 prime.
Yep. And for you guys.
Oh my goodness. All right. So there we go. And that's basically how you approach all these kind of problems here when you're drawing the complement base pair. That was kind of awkward. Sorry about that. All right. Let's take a look at what else we got. Yeah, so in your own words, explain how they pair. You guys can do that. Number 9 is more of the same. It's wanting you to draw the complement pairs for all these fragments. Do you guys need me to do any more of these? Or are you guys okay on these ones? Like number 9 is more of the same. You guys need me to do any more of those? Do the first one. Yeah. All right, you guys said they're okay. All right, for the next part here, I want to go and take a look at, so name the amino acids for each of the following codon sequences. So remember, DNA fragments are read in 3 nucleotide sequences. Each set of 3 is referred to as a codon, and then each codon is referring to a particular amino acid. So I'm going to go ahead and pull the chart up. You want to have this chart handy when you guys do the exam. You definitely want this chart. It's going to be useful. So the first one was AUU. Looking at our chart here, that corresponds to isoleucine. So with AUU becomes ILE, isoleucine. And then we just go through the chart here. So the next one was CAC. Oops. Let me pull that. Yep, so AU became ILE, and I forgot where I was at. The CAC was the next one. CAC becomes, looks like, histidine. And then the last one, and that's that there is GGA. What does that become? GGA, so G, G, and then A is right here. It's glycine, GLY. Like so. All right. So any questions about how to do these ones? You basically just read it off the codon chart. Pretty straightforward stuff. So that was number 11. This one's kind of the same way. I just want you to put it in a string rather than the little chart we just did. All right, we didn't go over this stuff here, so this part that's more biology, more deep dive in biology, we did not cover this. You guys should know this from your other bio classes. I'm not going to test you on it here. All right, so I did want to... Nope. I want to do number 22. So number 22 is I want to do the complementary DNA fragment here. Right. 3 prime, 5 prime. All right. So what should the first 3 letters be? So we're drawing the corresponding mRNA piece. What should the first part be? What should TGT become? Yep, ACA. Right, what's the next 3 in that one? Hang on, let me pull that chart. So GGG should become CCC. And then UAA, I see someone said for the next one. And then what about the last one? Oop. What should the last one be?
I think it's supposed to be CAA and then TAA.
Yep. All right. So then it's asking. The next question is asking you what amino acid sequence is this, and then I want to draw it just for good measure. So yeah, because one of you guys was requesting me to draw it last time. So I'm just going to translate this from the chart here. So ACA becomes threonine, THR. CCC becomes proline. CAA becomes glycine, and then UAA becomes stop codon. Yep, that's one of our stops. So we have a 3 amino acid sequence. Let me go ahead and. So once again, we were threonine, proline, GLN, and then stop. All right, so I just want to go ahead and draw this out here. So I actually want to draw out this peptide sequence. Remember, the convention is N terminus to C terminus. So I'm going to go ahead and have them charged as well. So remember, this carbon in the middle is where the R group is going to be attached. And if you're drawing a long sequence, I recommend just drawing them out like this. So second one, and then our next peptide. And I'm going to make these charged versions here. Like that. So then after you have this, all you need to do is pull up your amino acid chart and then plug in the different R groups. So THR, I'm looking at my chart right now that's on Canvas. It looks like it is that. And then the next one is proline, PRO. And then, oops, this is a tricky one. Looks like it's the ringed one. Right, like that. So proline is weird, guys. It had a weird structure, but that's what proline would look like. And then the last one, GLN. Oh, was not glycine. It was a different one. GLN is glutamine. So it's what, 3 carbons with an amide at the end. 1, 2, 3. That. All right. So I'm thinking on the exam, what I'm gonna have you guys do is I'm gonna give you guys a amino acid sequence. Sorry, a pep. I can't even speak today. A nucleotide sequence, and you guys have to draw the peptide sequence that would come from that. So what do you guys think? Could you do that? Okay. All right, so I'm thinking that's a really good way to kind of wrap the amino acids and DNA together, is to do something like that. All right. Did you guys want to work on anything else? We've hit every problem type in the handout. Remember, don't worry about this page here. This page, I mean, you should be able to know this page, but I wouldn't worry about it for the test. But all right, do you guys have any questions at all about DNA? All right, I'm gonna go ahead and cut the stream here, but I did want to chat more in the Discord chat, the voice chat, but I'm gonna go ahead and cut the stream right now. All right, guys, stay safe.